Hello everyone, I am back with other set of questions related to mathematical physics in CSIR UGC NET syllabus of vector algebra topic. So the following questions we'll be seeing it today. The questions are: if R vector is the position vector of any point on the surface of a cube of side L, then the surface integral R vector dot ds vector is, so we need to find the surface integral of the cube. To find the solution for this one, we need to use Gauss divergence theorem. So the Gauss divergence theorem is, according to Gauss divergence theorem, we can relate any surface integral of any vector with volume integral of the surface of the object of divergence of R dV. The surface integral is converted into the volume integral. So first we have to find the divergence of R, that is nothing but triple integral, or we also say it as volume integral, del vector dot R vector dV. So first we need to find del dot R. So we know that del vector is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z, and R is the surface vector, so that is written as x I cap plus y j cap plus z k cap. So now we will be finding del dot R, that is I cap dou by dou x plus j cap dou by dou y plus k cap dou by dou z in dot x I cap plus y j cap plus z k cap. Now to find del dot R, we will be just multiplying the coefficients of I cap in del with coefficients of I cap in R. Similarly, the coefficient of j cap will be multiplied with the coefficient of j cap in the R vector. The coefficient of k cap will be multiplied with the coefficient of k cap in the R vector. So the divergence will be del dot R vector will be dou x by dou x plus dou y by dou y plus dou z by dou z. So it will be nothing plus dou x by dou x is 1. The second term will also become 1. Similarly, the third term will also become 1. So we are getting del dot R as 3. So the volume integral can be written as it is a cube. So we are taking the limits of the volume as 0 to L, where L is the length of the cube. So 0 to L, del vector dot R vector dV is nothing but triple integral 0 to L, 0 to L, 0 to L. Del dot R is 3 and dV is dx, dy and dz. So the first integral is the limits for x. The second integral is the limits for y axis, and third is the limit for z axis. So we will be differentiating it, integrating it 3 times. That is, first we will integrate it for x. So integral of dx will become x 0 to L, then double integral 0 to L 0 to L dy and dz. So it will become 3L. Then y can be integrated as dy can be integrated as y 0 to L dz integral 0 to L. So it will become 3L into again 1L will be coming. So 3L square. Then the dz will be integrated as again z limit 0 to L. So we will get 3L cube as the answer. So the surface integral, just change it. The surface integral of R vector for a cube is nothing but 3L cube. That is our answer. Next question is, which one of the following matrices is skew symmetric? So for starting this problem, you should know two basic properties of skew symmetric matrix, or how we can say that a matrix is skew symmetric. The first property of skew symmetric is to prove whether the matrix is skew symmetric or not. The ijth element of the matrix should be equal to negative of the jith element of the matrix. That means if we transpose the matrix, then the negative of that transpose will be equal to the original matrix. The second point is, every skew symmetric matrix, the diagonal of the matrix should be 0. The diagonal should be 0 for a skew symmetric matrix. So with the second property, we are left with two options, whether either the B matrix will be skew symmetric or the D matrix will be skew symmetric, because in both B and D the diagonal is 0. In the other terms, diagonal is not 0, so they cannot be skew symmetric matrix. So first we will take, now if we consider the B matrix, so it is matrix B is given as the number values as 0, 3i minus 4, 3i, 0, 8 and 4 minus 8, 0. So I am making it two terms, a, I, j and minus of a, j, I for the same matrix. So if I take a, 0, 0 here, let me number it as 0, 1, 2, 0, 1, 2. So a, 0, 0 is 0 here, and similarly minus a, 0, 0 will also be 0. A, 0, 1 is 3i, and minus of a, 1, 0 is a, 1, 0 is 3i. A, 0, 2 is minus 4. Minus of a, 2, 0 is 4. So we will put a minus sign here. So both are coming same. Then a, 1, 0 is 3i here. A, 0, 1 is 3i. A, 1, 1 is 0. Again a, 1, 1 will be 0. A, 1, 2 is 8 and a, 2, 1 is minus 8. So if I put minus here, then it will be 8. If I put 0 minus, it will be 3i. So we can see that a, ij is becoming minus of a, ji. So matrix B is the symmetric matrix, skew symmetric matrix. Skew Next, which of the following matrices is Hermitian? For Hermitian, the properties are, we can prove that a matrix is Hermitian if Aij is equal to Aji conjugate. So here, if I take the matrix, first one, 0, I and I 0, then if I make it as conjugate 0, I 0 again. If I put minus, conjugate means we have to minus, put the sign, opposite signs in imaginary term. So it will become 0, minus I 0. So this term is not equal to this term. Aij is not equal to Aji bar for matrix A. If we go for matrix B, the terms given as 0, I minus I 0. So if I take conjugate of it, it will become 0 minus I and 0. And conjugate means we have to change the sign, so it will become 0 I minus I 0. So here you can see that Aij is equal to Aji conjugate. So that means matrix B is Hermitian matrix. Hermitian matrix. Similarly, the inverse of the matrix has to be found in this question. The matrix is given as A is equal to 1, 3, 3, 1, 4, 3, 1, 3, 4. The formula of finding the inverse of a matrix is, so here A is there, so A inverse we need to find. A inverse is equal to 1 by mod A adjacent of A. So first what you need to determine is whether the matrix is a singular matrix or non-singular matrix, because this formula is applicable only if the given matrix A is non-singular matrix. So non-singular matrix means determinant of A should not be equal to 0. That's a non-singular matrix. So first we have to determine what is the determinant of A. So 1, 3, 3, 1, 4, 3, 1, 3, 4. So the determinant is, first we will take 1, 4 to the 16 minus 9 minus 3, 4 minus 3 plus 3, 3 minus 4. So 16 minus 9 is 7. 7 minus 4 minus 1 is 4 minus 3 is 1, so minus 3 minus 3, so 6, so it is 1. So that means determinant of A is not equal to 0. So A is non-singular matrix. Non-singular matrix. So that means next we have to find what is adjacent of A. So adjacent of A is obtained by determining the cofactors. So here the matrix is given as 1, 3, 3, 1, 4, 3 and 1, 3, 4. So the cofactors of this matrix has to be found. Cofactors means for the first row there will be 3 cofactors, second row there will be 3 cofactors, and third row there will be 3 cofactors. So for we will be putting signs here, like for first row it will be plus, minus, plus, and again minus, plus, minus, plus, minus, plus. Like this we have to find. for finding the first row cofactors, we have to ignore the first row and the first column, and we have to cross multiply the remaining terms. So there will be 3 cofactors. First row should be completely ignored and the first column should be ignored in the first. So it will be plus 4 minus 3 plus 4. Then ignore first row and the second column. So what we'll get is minus 1 minus 3 plus 1 plus 4. I am including the signs to reduce the confusion in the upcoming parts. Then ignore the third column. Minus 1 plus 4 plus 1 minus 3. These signs we are assuming to make the calculation easier. So the first row cofactor will be 16 minus 9, that is 7. Then minus 4 plus 3, minus 4 plus 3, that is 1. 3 minus 4 minus 1. Minus 4 plus 3, so minus 1 minus 1. Similarly, for second row, we will get cofactors. In the second row, we have to ignore the second row. So ignoring the second row and the first column first, what we'll get is minus 3 plus 3, minus 3 plus 4. Then ignore the second row and second column, plus 1 plus 3 plus 1 plus 4. Then second row and third column, plus 1 minus 3 plus 1 minus 3. So the cofactors are minus 3, 1 and 0. These are the cofactors for the second row. Similarly, the cofactor for the third row will be found by ignoring the third row and the first column, then second and third. So cofactors of third row is found as minus 3, 0 and 1. You can determine it and find whether I have done it correctly or not. Minus 3, 0 and 1. So the adjacent of A will be written as the cofactors. So the first row cofactor we have obtained as 7 minus 1 minus 1. Then the second row minus 3, 1 and 0. Then the third row minus 3, 0 and 1. This is the adjacent of A value. So this is the value of, we have to find the transpose of this matrix. That will be the adjacent. So 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is your adjacent of A. Then we have to find A inverse. We know the determinant is 1 we have obtained, and the adjacent is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So the A inverse matrix is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. That's the inverse.